Hello and welcome to Math 253. My name is Lapuz, and in this video we'll be going over checkpoint 5.43. Here we have a linear transformation defined as t of uv. So u and v are inputs and our output's going to be x and y, where x is equal to u plus v and then y is equal to 3v. They want us to find the image of the rectangle where u goes from 0 to 1 and v goes from 0 to 2, and from the uv plane into the region R in the xy plane. And then we have to make sure t is 1 to 1, and then they want us to find the inverse transformation. Alright, so let us figure out what happens. So the idea is that we have uv plane here, and the u goes from 0 to 1 and the v goes from 0 to 2. So we are looking at trying to figure out where this image will be going after we perform the transformation. Sometimes the transformation t can be written as we have x and y, and so the x is equal to u plus v, and then the y is going to be 3v. And so given that transformation, what we want to do is we want to see what happens here on the xy plane. Okay, so standard things to do. First of all, I'm looking at this and say they're all linear. This is great news, which means this is a rectangular region, and also known as a parallelogram. And parallelograms get mapped to other parallelograms for these types of linear transformations. And we're touching a little bit on linear algebra, but that's kind of like how it is. And so what we want to do is we want to take a look at some sample points from UV plane, like 0, 0, 1, 0, 1, 2, and 0, 2. And see where that transforms onto the xy plane. And since parallelograms transfer to parallelograms, we should get a parallelogram on the xy plane. All right, so we get 0, 0. If we put 0 in for, this is our transformation table, so to speak. This is our uv onto our xy. And then we'll put these 4 points here. And then we'll put that into the transformation and see what happens. So 0 in for u and v gives us a 0 for x and a 0 for y. Another important property of a linear transformation is zeros get mapped to zeros. Here we have u is equal to 1 and v is equal to 0, so that's going to give us the x component of 1 plus 0, and then the second component of just 0. So here is 1, 1 comma 0. That's this point over here gets mapped. And now if we check the point 1, 2, let's put 1, 2 in here. I'm going to get an x value of 3 and a y value of 2 times 3 times 2, which is 6. So I'm all the way over here and all the way up here. Let's call this 6. 1, 2, 3. Let's say 3 is over here. So 3, 6 is our point. And then let's put 0, 2 in for u and v, and that gives us an x is going to be 2, and then the y is going to be 6 again. So 2 would be over here, and 6. Okay. So it looks like we have a parallelogram that looks something like this. This is going to be our image. So given a rectangular region, they're calling this G, we're going to get its image through this transformation as R. They're calling this R. Okay. Another way to do this is probably a more efficient way. If in case these things were not linear, I would probably want to put in v is equal to 0 from 0 to 1. And so when v is equal to 0, we'll let u go from 0 to 1. We're going to get this little bit of a space here. And here's the tricky part where u is equal to 1 and v goes from 0 to 2. U equals to 1. I'm going to get 1 plus v, where v goes from 0 to 2. I'm going to go from this line segment over here. So lines get mapped to lines as well, and that's why parallelograms get mapped to parallelograms. So that's our image. To show that t is 1-to-1, first of all, because it's a linear transformation, it's going to have to be 1-to-1. Well, 1-to-1 according to this, but the more formal way of showing that something is 1-to-1 is to suppose that your outputs of two different variables, so two different points, like u sub 1, v sub 1 is 1 point, and then we put that into the transformation where we put a different point, u sub 2, v sub 2. If they're equal, then that means the u's and v's have to be equal. Okay, so that's the general idea. So our conclusion should be uv, or u1 v1 equals u2 v2. So that's what we want our conclusion to be. So how's this going to work? Well, for each of these things, we have the output transformation. This is going to give us an x value of u plus v, comma 3v. So this is going to be u1 plus v1, comma 3v1. And this is going to give us u2 plus v2, comma 3v2. So these 2 points are supposed to be equal to each other, and so we'll set each of these components equal to each other. We're going to get u1 plus v1 equals u2 plus v2, and then we're going to get 3v1 equals 3v2. Well, from here, we're going to be able to say v1 equals v2, and if v1 is equal to v2, this is also going to conclude that u1 equals u2, and if they are equal to each other, then those points must be equal to each other. So this is our conclusion, which we wanted, and that shows that it is in fact 1-to-1. The last thing we want is to figure out what T inverse is. So we know that T of uv is equal to u plus v, comma 3v. Right? So that's our x and our y. They actually did say this. X is equal to u plus v, and then y is equal to 3v. So what we want to do to find the inverse is we essentially want to solve for u and v between these two equations. So from here again, we're going to get v is equal to 1/3 y. And if that's what v is equal to, we can put x is equal to, or x is equal to u plus 1/3 y. And so we'll solve for u. U is equal to x minus 1/3 y. Okay? And so now we have the u and the v in terms of x and y. So T inverse of x and y, so that's kind of like your input, and your output will be a u value. So it's going to be x minus 1/3 y, comma, and then my v output, this is your u output and this is your v output. Your v output is just 1/3 y, and then that's it. So this is your inverse transformation. All right, so just to recap, We found the image from G to R for this transformation, and we took advantage of the fact that they are linear transformations, and this is a linear transformation, so we just were, because we're coming from a rectangle, that's going to go to another parallelogram. We showed that it is 1-to-1. Let's just write the conclusion. So T is 1-to-1. And then we found the inverse transformation of T. So that's T inverse. All right, I hope that helps. Good luck.